Good morning, students. Today I am going to deal the second part of chemical bonding and molecular structure chapter, that is types of chemical bonds. There are different types of chemical bonds based on the nature of element types, based on the nature of molecule. The different types of bonds are ionic bond, covalent bond, metallic bond, coordinate covalent bond, hydrogen bond, van der Waals forces. This ionic bond, also called electrovalent bond. Electrovalent bond. Electrovalent bond. As I said, bond is nothing but an electrostatic force of attraction between atoms or ions or molecules. So when coming to ionic bond, the bond is formed between metal and non-metal. Metal and non-metal. Covalent bond, non-metal, non-metal. Metallic, metal and non-metal. Coordinate covalent bond, electron rich and electron deficient species. Let me give a brief idea about these different types of chemical bonds. So here it is formed between metal and non-metal. Hope you know what are metals and what are non-metals. Metals and non-metals. For example, sodium is a metal, chlorine is a non-metal. The bond between sodium and chlorine is ionic bond. Similarly, magnesium and oxide. Magnesium is a metal, oxygen is a non-metal. The bond is here ionic bond. How this ionic bond is formed? The bond is formed due to complete transfer of electrons from metal atom to non-metal. Here also same, magnesium transfers 2 electron to oxygen, which results formation of ionic bond between metal and non-metal. So it is formed due to complete transfer of electrons. What electrons? Valency shell electrons. Valency shell electrons from metal to non-metal. From metal to non-metal. So ionic bond is formed between metal and non-metal, and it is formed due to complete transfer of valence shell electrons from metal to non-metal. So for example, sodium transferred 1 electron to chlorine, magnesium transferred 2 electrons to oxygen. Now coming to covalent bond, it is formed between non-metal and non-metal. Non-metal and non-metal. Example, hydrogen, Cl. Hydrogen, oxygen, hydrogen, that is water. Non-metal, different atoms of different elements, atoms of same element. Atoms of different elements, more than 2 atoms. So bond between non-metal is covalent bond. How it is formed? It is formed due to mutual sharing of electrons. Mutual sharing of valency shell electrons of 2 or more atoms. two or more atoms. So ionic bond, also called electrovalent bond, it is formed between metal and non-metal. Covalent bond is formed between non-metal and non-metal. When coming to metallic bond, it is formed between metal and metal. The name itself indicates metallic bond formed between metal and metal. How it is formed? Due to loss of electrons. And when coming to coordinate covalent bond, that is formed between electron rich and electron deficient. We can understand this, what are electron rich and electron deficient, okay, after completion of covalent bond. So it is also formed due to sharing of electrons but not mutual sharing. Then hydrogen bond is formed between more electronegative atom and hydrogen. And van der Waals forces are observed in molecules. Even in hydrogen bond also formed between molecules. Okay, they are molecular bonds, and the other are atomic bonds. Ionic bond is atomic bond, that is between the atoms. Covalent bond is atomic bond. Metallic bond is atomic bond. But whereas these are molecular bonds, means the bonds are formed between molecules. We will see in detail study. Okay, this is just a brief idea, like what is ionic bond, how that is formed, where that is formed. Covalent bond, okay, that is formed between non-metal due to mutual sharing of electrons. Metallic bond is formed between metal and metal due to loss of electrons. For example, here sodium, metal and metal. Here the bond is metallic bond. Okay, right. Now let us discuss the first type of bond, that is ionic bond. Ionic bond. One of the chemical bonds, which is an electrostatic force of attraction between oppositely charged ions. Okay, it is an electrostatic force of attraction. It is an electrostatic force of attraction. It is an electrostatic force of attraction between oppositely charged ions. Okay, just a force of attraction between oppositely charged ions. Okay, and it is formed due to complete transfer of electrons from metal atom to non-metal atom. Metal atom to non-metal atom. So formed between metal atom to non-metal atom due to complete transfer of electrons. The direction is metal to non-metal. Okay, let us understand how chemical bond is formed between different metals and non-metals. Example, Okay, sodium chloride. Sodium chloride. In sodium chloride, sodium is metal and chloride is non-metal. Sodium is metal and chlorine is non-metal. Now to understand the bond formation between metal and non-metal, one must know the electronic configuration. Electronic configuration is 1s2, 2s2, 2p6, 3s1. Since the atomic number is 11, 2 plus 2 4, 4 plus 6 10, 10 plus 1 11. Now chlorine 1s2, 2s2, 2p6, 3s2, 3p5, whose atomic number is 17. You see the number of electron, 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 5 17. Now here both sodium and chlorine atoms are unstable as they do not have octet configuration, means 8 electrons in their valence shells. Here you see in sodium there is only one valence shell electron, whereas in chlorine 7 valence shell electron. So neither of the elements have 8 electrons in the valence shell. Now when coming to sodium to attain octet configuration, there are two ways. One is losing 1 electron, the other one is gaining 7 electrons. Losing 1 electron, then that attains 8 electrons in octet in valence shell. By gaining 7 electrons, also gains octet configuration. But the most convenient and easiest and less energy process is losing 1 electron. Losing 1 electron, because that's very easily we can remove the electron instead of gaining 7 electrons. Now after losing 1 electron, the configuration is going to be, okay, the element is going to be a charged species, that is sodium plus cation. So the electronic configuration is 1s2, 2s2, 2p6, where there are 8 electrons in the valence shell, which is equal to neon configuration, more stable gas. No, more stable configuration. Now chlorine, to attain octet configuration, okay, it should gain 1 electron or it should lose 7 electrons. Gaining 1 electron is more convenient rather losing 7 electrons. So chlorine is ready to gain 1 electron. Who will provide that 1 electron? Sodium will provide. Sodium is ready to lose electron and chlorine is ready to gain electron. So after gaining 1 electron, chlorine becomes Cl minus 1. And the configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6. So here chloride also attained noble gas configuration or octet configuration, which is argon element. Now Na plus attained neon gas configuration and Cl minus attained argon configuration. Now both are stable. Now here you see we have ions, Na plus ion and Cl minus ion. And you know very well, oppositely charged ions attract each other. That attractive force is nothing but electrostatic force of attraction. Electrostatic force of attraction. Electrostatic force of attraction. This electrostatic force of attraction is nothing but ionic bond. Ionic bond. Right, students? So ionic bond is formed between metal and non-metal due to transfer of electron. How many electron transferred here? 1 electron is transferred from metal to non-metal. After losing 1 electron, sodium attained octet configuration, which is equal to neon, and after gaining 1 electron, chlorine becomes Cl minus and attained octet configuration, that is argon. Okay, so in sodium chloride, sodium transferred 1 electron to the chlorine atom. Okay, copy it or take the screenshot of it. So ionic bond is just electrostatic force of attraction between oppositely charged ion, and it is formed due to complete transfer of electrons. Okay, the electrons are valence shell electrons, not inner electrons. As I told you many times, in chemical bond only valence shell electrons participates in bonding. Now coming to the second example. Second example, magnesium chloride. Magnesium chloride. The formula of magnesium chloride is MgCl2. MgCl2. Here magnesium is non-metal and chlorines are non-metals. When coming to the electronic configuration of magnesium, 1s2, 2s2, 2p6, 3s2. Chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. Similarly with the first chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. The first chlorine, it is shortage of one electron, okay, to attain octet configuration. Here also the second chlorine also shortage of one electron to attain octet configuration. The first chlorine required one electron, second chlorine also required one electron to attain octet configuration. When coming to the magnesium, you see in the last shell of magnesium there are only two electrons. Only two electrons. It is unstable. To attain stability, magnesium is ready to lose two electrons. I repeat, magnesium is ready to lose two electrons to attain octet configuration in its valence shell. Right. So magnesium is ready to lose two electrons, and each chlorine is ready to gain one electron. Now let us see. Magnesium transferred one electron to the first chlorine and second electron to the one electron. Second chlorine to one electron. Now after losing two electrons by magnesium, the charge on magnesium is M+2. And the configuration is 1s2, 2s2, 2p6, which is equal to neon gas configuration. And chlorine, after gaining one electron, that becomes Cl-1. And the configuration is 1s2, 2s2, 2p6, 3s2, 3p5, 3p6. Here also gain octet configuration. Now first chlorine also gain one electron and becomes Cl-1. Okay, configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Okay, attain octet configuration. Here also attain octet configuration. Magnesium also attained octet configuration. Now all are stable. Now you see negative charge, positive charge, negative charge. What type of forces we can see? Attractive force. Attractive force. Here also attractive force. What is this attractive force? Electrostatic force of attraction. Electrostatic force of attraction. What is this electrostatic force of attraction? Ionic bond. Ionic bond. So here MgCl2 is ionic bond. So magnesium transferred two electrons to each, one each to one chlorine. So magnesium chloride is a ionic compound as there are ionic bonds. Ionic compound. Magnesium chloride is ionic compound. So like this we can understand the formation of ionic bond between metal and non-metal. You can see magnesium oxide, aluminum oxide, calcium oxide, sodium oxide, sodium fluoride, sodium bromide, etc. Okay. Here electrostatic force of attraction is a very good attractive force. The force of attraction is very high. As a result of that, ionic compounds exist in solid state. Solids means more intermolecular force of attraction or intramolecular force of attraction, which results solid state. Okay, so ionic compounds are exist in solid state. Okay, next, properties of ionic bond and ionic compounds. Properties of ionic bond and ionic compounds. Properties of ionic bond and ionic compounds. So we'll see it in the next topic.